will introduce you to the topic of the relationship between average speed, distance moved, and time taken. First of all, let's look at the definition of each word. Average speed is how fast an object is moving in a particular moment. Distance moved is how much ground an object has covered during its motion. Time taken is the interval over a particular moment where change occurs. So, how are they related? As you can see that this is a triangle formula. At the top we have distance, speed on the bottom left, and time on the bottom right. I will explain how this triangle works. First, distance can be found by speed multiplied by time. Looking at a triangle, both of speed and time are at the bottom, so we multiply them. Second, average speed is equal to distance divided by time. Distance is at the top of the triangle, while time is at the bottom, so we divide them. Third, time taken. Therefore, time taken can be found by distance divided by speed. Knowing the relationship between them is very useful in real-life situations. For example, you are watching a car race and you want to know how fast you are. You can calculate the speed by the given information. A racer drives along a 1.5 miles track and reaches the finish line within an hour. As we know that average speed equal to total distance divided by total time taken, we take the 1.5 miles, which is the distance of the track, and divide them by time, which is 1 hour. As a result, we know that the car speed is at the rate of 1.5 miles per hour.
The advantages and disadvantages in using stem cells in medicine. What are stem cells? Stem cells are special human cells that are able to develop into many different cell types. Researchers believe that stem cell therapies one day may be used to treat serious illness, such as paralysis and Alzheimer's disease. Stem cells are divided into two main forms: embryonic stem cells and adult stem cells. Embryonic stem cells are obtained only from early-stage embryos, but adult stem cells can be found in our body. Stem cell research offers countless medical possibilities. The cells are undifferentiated. This means that they can be used to treat various conditions. Another benefit is that it can help progress cancer research. Embryonic stem cells are similar to cancer cells in that they can reproduce themselves indefinitely. By studying them, researchers may be able to develop treatments that are more effective against cancer cells. On the other hand, using stem cells has to do with the destruction of human embryos, which obviously, these embryos are already human beings. Another drawback is that we currently do not have a complete understanding of how embryonic stem cells work. So there might be a long-term health effects that we are not yet aware of. Last but not least, transplant stem cells can have a high rejection rates. In the other words, therapy may not be successful.
And the last topic of our group will be calculating the relative mass of an element from an isotopic abundance. For the calculation and the real-life application, I chose carbon, and this is basically the formula of how you calculate the relative atomic mass. We have carbon 12 and 13 in our calculation, and we basically get the sum of the isotope mass and time it by the percentage and divide it by 100, so you can get 12.011. which is the relative mass. Carbon 14 is really rare, so we don't include it in our calculation. The other reason is that it is radioactive and unstable, meaning that it can make up fission reaction and split itself apart. So paleontologists, or the person who studies history and process of evolution, will also be using carbon 14 properties. Meaning that the decay of carbon 14 over time will also be calculated with the ratio of carbon 14 and carbon 12, and then you will actually find the fossil's age. Isn't that amazing? So the general method of doing this is that you need to know the half-life of carbon 14 first. This means that you know the time taken for the process of radioactive decay of carbon 14 for it to be gone into half of its original quantity. This means that you need to know the ratio of carbon 12, and carbon 12 is stable. So you will know the carbon 14 quantity at that time. And then you calculate with the half-life, and you then know the age of the fossil right now.